An aircraft is climbing at an angle of 20 degrees to the horizontal. What horizontal distance has it covered when it has flown 100 meters? So we're having an aircraft. This is the horizontal distance. They're telling us that this aircraft is climbing at an angle of 20 degrees to the horizontal. So in our sketch, we know that if this is the starting point, it is moving up and it is moving at a degree, at 20 degrees to the horizontal. This is the horizontal we're talking about. They're asking us to find what horizontal distance has it covered when it has flown 100 meters. So if it flies up 1,000 meters actually, if it goes up 1,000 meters, what horizontal distance will it have covered? This is the horizontal distance they are interested in. Let's call it x. So you realize that for us to be able to find our horizontal distance in our sketch, we have formulated the right angle triangle. And if we formulated the right angle triangle, then we can get the value of x using trigonometric ratios. So from our SOHCAHTOA, you realize that we have an angle, and at this angle, this value of x, this length we are looking for, is adjacent. So we have the adjacent side, and we also have the hypotenuse. So if you come here and check to see which trigonometric ratio to use, whether one that has got both adjacent and hypotenuse is the cos one. So you shall come here and say that the cosine of 20 degrees is equal to adjacent, which is the x you're looking for, over hypotenuse, which is 1,000. So if you make x the subject of the formula, it's going to be 1,000 times cosine of 20. 1,000 times cosine of 20 gives us 939.69 meters. So that will be the horizontal distance this aircraft will have traveled. In our next question, they are telling us that a 5-meter pole is leaning against the wall of a house so that the angle between the pole and the wall is 40 degrees. Calculate the height of the top of the pole above the ground. Again, we'll draw a sketch. They're telling us it's a 5-meter pole and it's leaning against a wall. So if this is the wall we are talking about, a 5-meter pole is leaning against the wall of the house so that the angle between the pole and the wall, so if this is the wall and that is the pole that is leaning, so the angle between them is 40 degrees. Calculate the height of the top of the pole above the ground. So this is the top of the pole, that is the bottom of the pole. And they are asking us to find the height of the top of the pole, the height of the top of the pole above the ground. This is our ground, down here. So if you look at our sketch, still, they're telling us that we realize that our sketch ends up into a right angle triangle. And if you are to get this height, it means we are trying to find this height. We use trigonometry. The pole is 5 meters, so it means that this side here is 5 meters. Still, when we look at our SOHCAHTOA, we look for which trigonometric ratio is suitable to use. If you look at this 40 degrees, we say the hypotenuse is the longest side. So we have the hypotenuse, and we have this side, it is adjacent to 40 degrees. This one is opposite. This one is adjacent, and it's the one we are looking for, h. So we have adjacent and hypotenuse. When you come here and look for which one to use, we have adjacent there, we have hypotenuse. So still again, we are going to use cos. So it's going to become that the cosine of this angle, which is 40, is going to be equal to the adjacent, which we are looking for, h, over the hypotenuse, which is 5. And our value of h is going to be 5 times the cosine of 40. And the value of h, our answer is going to be 3.83 meters. Please remember to share this video on other video sharing platforms, and also subscribe and hit that like button. Thanks for watching, and this is Arnold Rwangakuramya for Kisembo Academy.